I interview, people like, Dr. Teitelbaum and Thomas Levy and leaders in the integrative space, talking about various subjects. Also have a couple of podcasts. One is Integrative Lyme Solutions with Dr. Karlfeldt. The other one is Integrative Cancer Solutions with Dr. Karlfeldt. Have a TV show as well. Used to have a local TV show here that aired for about 100 episodes. So and run a busy clinic here in Meridian, Idaho, where we focus on quite a bit of integrative oncology, but any type of health concerns that people need help with in an integrative fashion. We have a number of docs there, orthopedic doc, medical oncologist, chiropractor, nurses, nutritionists, etc. So we have a lot of fun here. So the subject that I'm going to be chatting about today is about a single molecule called Ampk. And let me share the screen here. See here, slideshow. Great. And this is actually it's a fascinating molecule. It's a metabolic and redox sensor. So I'm just going to do a little minute review on an article that I went through and kind of dissected. So here's just kind of the overview, talking about it. So the AMP, activated protein kinase, system, acts as a sensor of cellular energy status that is conserved in all the eukaryotic cells. So it is for any energy that's taking place within the cell, this functions as a sensor of that energy, which makes it become a pretty core component within what happens within the cell. And it has three different subunits. You have the alpha subunit, which is catalytic, breaking things down. And you have the beta subunit, which contains a glycogen sensing domain, checking and see where the sugar level is. And then you have the gamma that contains two regulatory sites that bind, the activating and inhibitory nucleotides AMP and ATP. So that's the one that kind of drives and whether we're going to do more AMPK or more AMP or more ATP, depending if we need more energy, less energy within the cell. And they have different hormones and cytokines, like insulin, leptin, adiponectin, that interacts and with this system, and it appears to play a key role in maintaining that energy balance at the whole body level. So it becomes a really key component then in regards to any kind of energy production, metabolic processes, etc. So it's recognized as the quintessential metabolic regulator. So that's how it's important. So it plays that important of a role. So this, I just want to kind of throw this screen early. We're going to look at it again, but this is just to kind of see the central role of AMPK and how it plays a role in all these different functions, like the glycolysis, vascular function, AMP ATP ratio. You also have things like fatty acid oxidation and synthesis and lipolysis, protein synthesis, mitochondrial genesis. So you have all these different functions, and also you see that the calcium ions, so kind of the transport of ions, through cell wall membranes and the mitochondrial membranes. So it plays a huge central role in the body. So to be able to recognize how we can then support its function and regulate some of its function can become key in in supporting our patients' health. So the AMP activation then, so AMPK is sensitive to the AMP ATP ratio. So it is therefore activated as a consequence of any kind of cellular processes, normal or anomalous, that either decreases ATP levels or increase AMP concentrations. So either one of those will then have an impact on the AMPK and activates it. Either decreased ATP levels or increased AMP concentration. So that AMP ATP ratio then becomes quite important. So we have things like hypoxia, glucose deprivation, or metabolic inhibition of ATP synthesis. They will all then activate AMPK. And increased examples then of increased ATP synthesis include activation of motor proteins, activity of ion channels or pumps, and utilization of biosynthetic pathways. AMPK modulators includes, like we mentioned prior, the cytokines, things like leptin, adiponectin, ghrelin, cannabinoids, interleukin-6, ciliary neurotrophic factors, certain drugs, like metformin plays a huge role. And you also have some plant-derived compounds like berberine, resveratrol, and etc. See here. Make sure. Okay. So looking then at this screen here, so we can get a kind of a feeling again, and you see how what activates, and then by activating, so you have different nutrients that then turns on cellular function, and then ADP is increased then to ATP, which is our energy currency within the cell. And increased ATP then deactivates the AMPK, which then slows down then the energy consumption, which then will lead towards more of an anabolic process where we are then building tissue up. We're not consuming energy, we are building tissue up. And so that will then increase in the ATP, which will then increase the AMPK, that will then activate the AMPK. So and kind of see how that cycle, which then when that's turned on, then the metabolism is increased, and then nutrients are used and to produce more energy. So it's that kind of cycle that keeps moving, depending on the need of the cell. So here we can then again see the different factors that can then play a role in impacting AMPK, like the leptin, adiponectin, interleukin-6, CNTF, berberine, resveratrol, and then also the impact that it has on the body, the AMPK, increase in the glucose uptake, increase glycolysis, increase fatty acid oxidation and mitochondrial biogenesis, and then decrease all the anabolic processes like protein synthesis, glycogen synthesis, sterol synthesis, fatty acid synthesis. So this is kind of the function then of the AMPK at a snapshot. So we have then the activation, deactivation cycles of the AMPK, and so again, activation of AMPK is initiated by a high AMP ATP ratio and is triggered by AMP binding to the gamma subunit and a phosphorylation of THR172 of the alpha subunit. So this is catalyzed by AMP kinase. And then the reverse, when you do the deactivation, occurs when the protein phosphatase dephosphorates the alpha subunit, returning AMPK to a basal inactive state. So this is what happens when you activate AMPK. You have the phosphorylation, and then when you deactivate, you have the dephosphorylation that takes place. And in what section of the AMPK that's impacted. So here's just to kind of see what happens when you inactivate. You have the protein phosphatase that inactivates it, and then you have the AMPK kinase that activates it, and which areas that it works on. So upstream AMPK kinases, so these are the ones that are then acting on the AMPK, functioning upstream. The more important ones are things like LKB1. It's a serine threonine tumor suppressor kinase, and it appears to be critically involved in the activation of the AMPK alpha 2, but not the alpha 1 subunit of the AMPK. Then you have, and this one also plays a huge role, ICAR, which is also an important activator of AMPK. It's an adenosine analog taken up by muscle and phosphorylated to form ZMP, which stimulates AMPK activity and glucose transport in skeletal muscles. So that's a strong activator of the AMPK. And here you see the interaction also between the LKB1 and the ICAR. So where LKB1 is essential for ICAR-induced activation of AMPK. And any kind of stimuli that amplify also the intracellular calcium ions, such as bradykinin and thrombin, that also activates AMPK alpha 1. So if you support the ionic health within the cell, well, the calcium ions, excuse me. See, it's what happens when you talk a lot throughout the day. So, and then we're looking, so that was the upstream. And then we're looking at the downstream targets of AMPK. And there's a lot of them. I mean, they're finding more and more targets and impact on AMPK on different cellular processes and somatic processes, etc. And so it's rising into the hundreds, the different targets. So here are just some examples, like acetyl-CoA carboxylase, HMG-CoA reductase, carbohydrate metabolism, like glycogen synthase, cell signaling, like endothelial nitric oxide synthase, insulin receptor substrates, ion transport, like cystic fibrosis transmembrane conductase regulator, and transcription, like hepatocyte nuclear factor 4 alpha, and also it functions as a transducer of regulated Krebs activity. As you can see, so these are just a few examples, but it's just hundreds of them that AMPK then that impacts. So going back again to the screen that we looked at before, so you can kind of appreciate again, the activity and all the the upstream and then the downstream activities, what upregulates, what downregulates, and so forth. So role then of AMPK in cellular synthetic function, and so you have a HMG-CoA reductase, as a rate controlling enzyme of the mevalonate pathway, the metabolic pathway that produces cholesterol and other isoprenoids. So AMPK then plays a huge role then in any kind of cardiovascular health and in regards to cholesterol manufacturing, and also in regards to steroids, steroids manufacturing, since cholesterol is a crucial building block for that. The catalytic activity then of the HMGR, is inhibited by the phosphorylation of the serine 872 by AMPK. So again, this is something that's controlled by AMPK. AMPK can also be activated by adiponectin, and this can reduce cholesterol synthesis and consequent atherosclerotic lesions, and also inhibits protein synthesis at multiple points. So these are a couple of areas where it does that. One, phosphorates and activates a eukaryote elongation factor, 2 kinase, and also AMPK also inhibits the mammalian target or rapamycin complex, inhibiting effects of both IGF-1, which is a growth hormone, and insulin. So plays a role in both of those. And then we have AMPK's role in cell growth and cell death. Which is really interesting when you're dealing with cancer, where you want to kind of control the replication of cancer and stop the cell, create a cell cycle arrest. So AMPK then plays a role in that, and 2 different locations, both at G1 and S. G1 plays a huge role in the cell growth in itself, and then the S aspect of the phase cycle, cell cycle, has to do with the DNA copying, and it does this then through the involvement of tumor suppressor p53, which we all know plays a key role in regards to cellular repair, and then also apoptosis. When we have a lot of the mutated form of p53, then it is hard then to kill cancer cells, even with chemo radiation, because if that is dysfunctional, then you're not able to trigger that apoptotic switch to kill it off. And then also you have the cyclin-dependent kinase inhibitors, P21 and P27. They also play a huge role, especially at the S section of the cell cycle with the DNA copying. So AMPK appears then to reduce the mRNA stability of critical cell cycle regulators like the cyclin A and cyclin B1. And so in this complex and interactive matter, AMPK can also function then to negatively regulate cell cycle progression, with a final consequence of inhibiting cell growth and proliferation. So it can then control a lot what happens within normal tissue in itself, but then if you're dealing with a lot of integrative oncology, this becomes really important then to control that cell growth and proliferation of abnormal tumor cells. So here's just a graph just to kind of see that again. We have the different path. You have working then on the p53, and then also on cyclin A1 and cyclin B. Where the p53 working the G1 phase arrest, and then the cyclin A1, cyclin B working more on the S phase arrest through mRNA then instability. So the different functional roles then of AMPK. AMPK plays an important role then in influencing the function of ionic channels on the plasma membrane as organellar surfaces inside the cell. And obviously the ionic channels are crucial for any kind of energy production, and then also to regulate pH level and any kind of nutritional transport through the cell wall membrane, but also then through the mitochondrial membrane for energy production. AMPK then also controls appetite through complex and multi-loop feedback system that integrates in the arcuate nucleus of the mediobasal hypothalamus. So see that it has a control then within the hypothalamus. AMPK is activated in an exercise, most likely by skeletal muscle contraction. So by exercising, we're then able to increase the AMPK, and that will then obviously, as we know, all the benefits that AMPK has in regards to the censoring of appropriate energy within the cell and controlling tumor growth, regulating blood sugar, protein synthesis, fatty acid synthesis, all of that. We can then reap those benefits just simply by exercising. And we have leptin, which is one of the most important adipose-derived hormones, is also known to increase AMPK activity in skeletal muscles. You also have then ghrelin, a hormone produced mainly then by the PD-1 cells lining the fundus of the human stomach, and the epsilon cells of the pancreas that stimulate appetite. That also regulates AMPK activity in the hypothalamus as well as peripheral tissue. And what's interesting here, in adipose tissue, insulin will inhibit AMPK. So obviously then if we exercise more and then we have less adipose tissue, then we can then increase the amount of AMPK that we have in the system. So AMPK then in health and disease, it plays a huge role in on obesity, since it plays a key role in fatty acid production, and also in any kind of anabolic activities. Also plays a huge role then in the regulation of blood sugar. Aging, what they found is AMPK overexpression can increase lifespan by as much as 15%. So again, increasing the AMPK within the system can be really beneficial. And we're going to talk a little bit about some natural agents that can be used to increase AMPK. Malignant disease, we talked a little bit about that earlier in regards to cancer and the cell phase arrest, that can be done using AMPK. But here you have epigenetic modulator, AKT, that activates mTOR signaling, which is an important signaling in regards to cancer, by inhibiting AMPK activity. LKB1, which is one of these upstream regulators of AMPK. And the inactivation and mutation loss of this LKB1 is linked then to 50% of non-small cell lung cancer and high grade in pseudoductal breast cancer. So they've seen a direct correlation there. And the ACAR, which we talked about as well as being one of those upstream regulators, has been shown to inhibit growth of established tumor cell lines, both in vitro, and include things like colon, breast, prostate, gastric, and glioma. And also AMPK shown to increase expression of the P53 that we talked about earlier, that plays a key role in regards to apoptosis, or the oxidation of cancer cells as you're going after them. So then we have also neurodegeneration. You have the AMPK alpha 1 and alpha 2. They're both highly expressed in the brain. And AMPK in the astrocytes is involved in ketogenesis and also in the prevention of the apoptosis of brain cells. So, prevention then of things like, Alzheimer's disease and dementia and any kind of neurodegenerative diseases. ACAR treatment has been shown to protect neurons from injury by agents like glucose deprivation, hypoxia, excitotoxicity, like different heavy metals and chemicals, and also amyloid and beta peptide, which is a peptide connected to neuronal apoptosis and Alzheimer's disease. Also it plays a key role and then in diabetes and blood sugar regulation. And what they've seen is that AMPK mediated glucose uptake is complementary to insulin, which means that even without production of insulin, you can use the AMPK mediated glucose uptake system, and that works just as well. So that's a great complementary to insulin if you have insufficiency in that area. And then looking then at vascular endothelial function, which is really interesting, especially with what we're dealing with COVID and its impact on the ACE2 receptors and endothelial lining inflammation, etc. From both COVID and then also then possibly from the vaccine as well. So they're seeing then there's an intricate balance, between AMPK signaling and the redox balance in the vascular milieu. So as the body is oxidizing and reduction, the antioxidant activity and oxidizing activity, within the blood vessels to control inflammation. See that the AMPK signaling plays a huge role in that. So again, by supporting AMPK, you're then more able to control the redox balance, the inflammatory balance, within the blood vessel milieu. AMPK has been shown to inhibit the formation of reactive oxygen species by NADPH oxidase and stimulate nitric oxide production by the endothelial nitric oxide synthase. So again, controlling the production of oxidative substances that can then run amok, again, something that we've been dealing with regarding this COVID crisis and the spike proteins and their effect on the system. And one important hallmark of endothelial dysfunction is a decreased bioavailability of nitric oxide, which is a central vasodilator molecule that helps regulate vascular tone.
Oh, I got more up here.
AMPK can also influence the cellular redox state via prevention of tyrosine nitration and inhibition of prostacyclin synthase in endothelial cells that have been exposed to high glucose. So if you're dealing with blood sugar issues and by supporting the AMPK, you can then reduce the impact, the endothelial impact of the blood vessels, from that glucose or elevated blood glucose. And then you have metformin, which talked a little bit of being a pharmaceutical that can then activate the AMPK. So metformin-induced AMPK activation is beneficial to endothelial function via then the heat shock protein 90 mediated activation of the endothelial nitric oxide synthase. Which then will then impact the production of nitric oxide. And nitric oxide activates AMPK in the endothelial cell through the calcium ion dependent mechanism. And AMPK activation can itself increase nitric oxide release. So as you see, there's a positive feedback loop in between the two. So AMPK will help increase the nitric oxide will help to increase the AMPK. So if you go after or support AMPK, you can increase nitric oxide, but also using agents, like L-arginine or things that help to support nitric oxide production can then also increase the AMPK. And then I thought this was interesting. Hydrogen peroxide, can mediate AMPK activation independent of changes in that AMP-ATP ratio in endothelial cells. So So just simply by doing, if you do hydrogen peroxide IVs, for instance, that would then increase the AMPK activation, and that will then have the beneficial effect of the redox control, within the vascular milieu, and production of nitric oxide, and all the different things that you can benefit from then from the AMPK, from the hydrogen peroxide. So in addition to just the direct effect of hydrogen peroxide, this is just one of those downstream effects that it can have, along with a number of other cytokine effects that it has, that it triggers through an IV. So net effect then of AMPK, you have stimulation of hepatic fatty acid oxidation and ketogenesis. So again, oxidize bad fats within the liver, and the production of ketones for energy. You have inhibition of cholesterol synthesis, lipogenesis, and triglyceride synthesis, inhibition of adipocyte lipolysis and lipogenesis, stimulation of skeletal muscle fatty acid oxidation, muscle glucose uptake by pancreatic beta cells. AMPK acts as a metabolic master switch, regulating several intracellular systems, including the cellular uptake of glucose, and the beta oxidation of fatty acids, and the biogenesis of glucose transporter 4, which is the kind of that glucose transport system that takes place with or without insulin, and also regulating the mitochondria as well. Then you have AMPK and mitochondrial biogenesis, which obviously we want our mitochondria to be healthy, and as many as possible of them within a cell, to increase mitochondrial activity and also support the health and repair of the cell. So AMPK potently control organellar biogenesis in response to cell stress or high metabolic demand. Mitochondria, so high metabolic demand, like exercise, obviously would produce cell stress and also increase the metabolic demand. So again, that will then increase the AMPK, and then also it will support then mitochondrial biogenesis. Mitochondrial biogenesis is activated by numerous signaling elements, typically triggered in cellular stress that we're talking about in response to environmental stimuli. Mitochondrial density is critically reduced in the face of insulin resistance and lipid accumulation in muscle tissue. So again, that becomes really important then in regards to controlling what you eat. If you eat a lot of sugar, obviously you are then going to become more insulin resistant, and then also you'll start to have lipid accumulation taking place. Then you have NRF1 and 2, the nuclear respiratory factor 1 and 2, transcriptionally control the genes that encode for all 5 electron chain complexes in the mitochondrion. And the nerve expression is increased by chronic AMP activation. So by increasing the AMP activation, we can then impact the nerve expression, which then impacts all the different complexes within the mitochondria through the electron chain transport. And so that becomes huge, obviously, for any kind of mitochondrial and metabolic dysfunction within the cell that can lead to a lot of different diseases, and cancer being one of them. Mitochondrial biogenesis regulator, PGC1 alpha, is increased and in response to activation by AMPK. So these are just some examples of the AMPK and its impact on the mitochondria and the mitochondrial biogenesis. So metabolic effects of AMPK activation. We talked about the GLUT4 already, so uptake of glucose across the plasma membrane via GLUT4 is regarded as a rate limiting step in glucose uptake by cells. So that's how it's important is, and that's how important AMPK play in that role. AMPK activation leads then to GLUT4 translocation, recycling GLUT4 by phosphorylating AS160, which then binds to 14-3-3 proteins, increasing GLUT4 expression by involving the transcription factors MF2A and 2D, myocyte enhancer factor. AMPK inhibits the glucose-stimulated transcription of fatty acid synthase, the enzyme responsible for synthesis of fatty acids. So, these are some of the effects, working on the glucose and then also on the fatty acid production, the AMPK. So it plays a huge role then in weight loss, obviously, looking at this. So AMPK plays a critical role in determining the fate of fatty acids through the regulation of specific substrates. AMPK phosphorylated ACC, which is a biotin-dependent enzyme that catalyzes the irreversible carboxylation of acetyl-CoA to produce malonyl-CoA, which is the most important function of ACCs to provide malonyl-CoA substrate for the biosynthesis of fatty acids. So AMPK then controls that activity. So AMPK activity is reduced in aortic endothelium and muscle in obese rats compared with lean controls. So again, the importance then of controlling your weight, because then you're reducing the AMPK activity within the lining of the blood vessels, and that will then cause them to be more prone towards inflammation, because the regulatory, the redox regulation will be less, when you have less AMPK activity there. So here is just, I thought this was interesting just to kind of see what is out there, and there are a lot of them out there, but these are just kind of some examples of things that can activate the AMPK. So by bringing some of these tools into your toolbox, it can really help you then benefit from all the kind of downstream effects of AMPK. So you have methylene blue, which is something we use quite a bit here at my center for a number of different reasons. But here you can see it alleviates experimental autoimmune encephalomyelitis by modulating then the AMPK, SIRT1 signaling pathway, and the Th17 Treg immune response. So it helps to kind of control that inflammatory signaling or immune response. And then we have doxorubicin, which induces an apoptosis and autophagy by reducing basal phosphorylation of AMPK and its downstream target, acetyl-CoA carboxylase. So you can see kind of how doxorubicin then triggers the cell death of cancer, using then working through the AMPK. And then we talked about metformin, which inhibits the mitochondrial respiratory chain in the liver, leading to activation of AMPK, enhancing insulin sensitivity for type 2 diabetes, and also metformin then can then trigger autophagy, because of that. ACAR, the adenosine analog that we were talking about before, it's an AMPK activator. Regulates the glucose and lipid metabolism, inhibits pro-inflammatory cytokines, and inose production is also an autophagy and also a mitophagy inhibitor. Gingerol, in ginger, so here you can use ginger to activate the AMPK, and the gingerol exhibits a variety of biological activities, including then anti-cancer, anti-inflammation, antioxidation. So you can use something as simple as ginger. The next one is Ginkgo Biloba, the ginkgolide C, it's a flavonoid that exists in Ginkgo biloba that also activates an AMPK, possesses a number of different biological functions, like decreasing platelet aggregation and ameliorating Alzheimer's disease. There's a lot of studies, connecting Ginkgo biloba and also Alzheimer's disease. Then you have the different, you have Amerigentin, that can be isolated from Swirtia or gentian, gentian roots, which is a very bitter herb that's used a lot to stimulate an appetite and also liver and digestive function. So Amerigentin exhibits many biological effects, including then antioxidative, anti-tumor, anti-diabetic activities. Amerigentin exerts hepatoprotective, immunomodulatory effects. Amerigentin promotes apoptosis, as arrest, G2M cell cycle. So that's a different area of the cell cycle that we talked about earlier. Down-regulate, this very important pathway, signaling pathway, the PI3K, AKT, and mTOR. Amerigentin exerts beneficial vascular metabolic effects by activating the AMPK. And then we have Gomycin J, which exists in Schisandra, which is a common both Ayurvedic and then also exists within the traditional Chinese medicine, and has demonstrated to have a vasodilatory activity, suppress lipid accumulation by regulating the expression of lipogenetic and lipolytic enzymes, inflammatory molecules through activation then of MPK, LKP1, and also the calcium ions. And also a potential benefit in treating the non-alcoholic fatty liver disease. And then we have danthron, that comes from just Chinese medicine, the rhubarb, Chinese medicine rhubarb. Also found, regulate glucose lipid metabolism by activating AMPK. And then we also have berberine, dimethylene berberine is a natural mitochondria targeted antioxidant. And they've seen alleviate mice colitis, inhibits inflammatory response by inhibiting NF-kappa beta pathway and regulating the balance of TH cells. The berberines serve as a MPK activator for treating the non-alcoholic fatty liver disease. Obviously, berberine plays a huge role also in blood sugar regulation, and also when you're dealing with cancer, to shut down some of the fermentation cycle within the cancer to drive energy then through the mitochondria, and instead of the production then of lactic acid, which promotes cancer signaling. So I believe that is it. Yeah, if you have any, please let me know if you have any questions. I know it's a huge amount of information and also, a lot of technical things, but in reality, it's just to show how AMPK plays such a huge role in kind of regulating the energy production within the cell, and then also a lot of the redox and metabolic activities.
Okay, Michael, could you give us a little bit of an overview of how you might use it? I mean, you gave us a lot of information, a lot of statistics, but here I am sitting in my office, and somebody came in today and says, "What do you have for anti-aging?" and we're reading through this, and I'm saying this probably would have been perfect.
Yeah, so the AMPK is what you would do then is using strategies to support activation of the AMPK, and so you can use the different natural agents. You can, in addition to metformin, methylene blue, so you can bring in a number of those natural agents in to activate the AMPK with all the downstream benefits of it. But then also then using that as an educational tool for the importance then of creating lean body mass, making sure that you stay active, to increase AMPK that way, and then also to regulate, what you are eating, to reduce and the production of fats, because they see, the more overweight an individual is, the less AMPK activity you have, and then all the health, detrimental health aspects, that comes along with it. So I think it can become a good educational tool, in addition to then, taking steps and to really kind of drive up the activity of it.
Well, being a hormone guy, we were talking here while you were back and forth, and it seems to me that the pathways that you outlined, that some of the uses and are closely aligned with growth hormone.
Mm-hmm.
Is there any correlation between them? Is there any?
Yeah, so the AMPK is more of a kind of catabolic, and obviously growth hormone and IGF-1 are more the anabolic aspects. So so by activating the AMPK, you will it's more breaking down unwanted tissue. Like talking, you're seeing a number of these different natural agents. They support autophagy, where it just kind of cleans out unwanted tissue. So it becomes in a balance a little bit between the anabolic activity of the IGF-1 and on growth hormones, and then the AMPK.
Okay. Dr. Ching asks, what are tests needed to optimize AMPK? Are there any?
Yeah, I actually I think Dr. Halassa was mentioning it.
Yeah. I think there is a test. It's ADP, ELISA test. You measure the ADP, and there's a lab for it. It tells you indirectly the AMPK activities, and I'll try to post it in the chat room. But yes, I think it's a good thing to monitorize your treatment by using a diagnostic testing. So when you start doing all your treatment, before you do it, you test it, and then you do your treatment after 3 months, 6 months of all your integrative therapies, and you want to give a good news to the patient. You tell them, hey, you start with ADP at level this before, and now your ADP is high. That's mean your AMPK is high. That's mean we extend your lifespan, because if you have a high AMPK, it's like telomeres. It indicates that you're slowing the process of the aging, and it's a good indication of general health.
Okay. Next question: is it safe to use metformin even if you don't have diabetes or pre-diabetes? I think
yes. A lot of people use metformin as an anti-aging substance, and I use it a lot in regards to cancer, as one of the repurposed drugs, that care oncology, that we have that doxycycline, some statin, aspirin, mebendazole, and so it can be part of that kind of a protocol in regards to supporting then the kind of protection against cancer. So it has both anti-aging effect, AMPK benefits. So yes, some people do that just as a preventative and anti-aging tool. Metformin. Obviously, you want to kind of make sure your liver's doing okay and kidneys are fine, and so that they're not impacted. Or if you, rather than use a natural, the berberine, I like dihydroberberine just because it is more easily assimilated in the gut. About 40% of us have a issue absorbing berberine through the gut lining. So dihydroberberine is just more easily absorbed and bioavailable. So if a person is concerned about metformin, then maybe using something like dihydroberberine.
Okay. We got a thank you from Dr. Burgess for your intense and inspiring information.
Thank you.
That's all of the questions that I have here. Anybody else have any questions, comments? Let me ask you this question. So I'm looking on my trusty Google here, and I put in AMPK, and it says life extension, AMPK metabolic activator, $28.50 from iHerb, which we can probably get it for half that, wholesale. So are these things worth anything?
Yeah, but I think if you and I'm not sure about that product in itself, but I think bringing things in like the ginkgo, ginger, this different phenols, polyphenols will all really kind of work very well on activating AMPK. So yeah, it should be part of anyone's health protocol is to have a number of these different polyphenols, in
So just as example, this one has 430 milligrams of calcium. It's got 500 milligrams of hesperin from orange extract, I guess orange peel, and then gynostemia, which is I think a Chinese herb, 450 milligrams. That's what's in this AMP activator, 30 tablets for $28.
Yeah, and it depends on what kind of calcium. So you like the calcium ions, as we mentioned, by supporting so having good bioavailable calcium is really beneficial in regards to activating the AMPK. But then you also have the opposite is true as well. If you have a poor quality calcium and that just accumulates in the cells and clog up the metabolic process of the mitochondria within the cell, then you will have the opposite effect. So just because it's calcium, you want to make sure that it's a good, easily usable, something that can go easily into an ionic form type of calcium. Obviously not calcium carbonate.
Well, I will go with more natural thing, and I investigate cod liver oil is the best rich all fat soluble vitamins is in the cod liver oil, and I think that will be one. And then you have Spirulina Probiotics, and the reason why I like that the Spirulina Probiotics, because you are manufacturing the polyphenols and chlorophylls and nitroxide donors. So if you do both Spirulina, which contains almost all water soluble vitamins and polyphenols and chlorophylls, and you are manufacturing it, not in your gut, and you do cod liver oil, which cover the fat side of the multivitamins. I think those two things, along with low dose methylene blue and berberine, but I would not do metformin, because long-term use of metformin can interfere with mitochondria. It does have short-term, but I don't think they made a good investigation for years of use of metformin. I would use berberine better. So those are the three things that I would use. I mean, you can use polyphenols, but they're costly. So you want to find something that's more affordable. Because if you start saying, "Oh, I want to get curcumin, ACGC, all this stuff," then it's going to be too much. But if you can come up with 2 or 3 items that contain everything, which is Spirulina Probiotic and cod liver oil and berberine and methylene blue, I think that will cover everything you need to activate the AMPK. That's my opinion.
Or the AMP metabolic activator from Life Extension for $30. I'm just trying to, I don't mean to be flippant. I'm just trying to kind of get a sense of where we can put this in. You guys are light years ahead of us with your pathways here. So we're simpletons out here in the hinterlands here. So you need to kind of give us the spoon-fed version. So
Yeah, but even, I mean, you have like I mentioned, a number of those herbs are inexpensive. Like ginger is not expensive. And gentian is not expensive. Ginkgo is not expensive. I mean, so just looking at some of those, can be really helpful.
Okay. All right. So can you give us a too much dairy today, huh?
Actually, not enough.
Oh, okay. Well, that would be okay. Can you give us a summary here of my head's kind of spinning from all of this. And by the way, everybody, just to let you know, we'll have this up on the website usually within 48 hours. AOSRD.org/webinars. I'll put it in the chat. Okay.
Yes, I think the summary relates to just the impact of the AMPK in regards to the endothelial redox signaling, controlling of inflammation and pathogen accumulation within, excuse me, within the endothelial lining of the blood vessels. So that's a huge factor. The nitric oxide production, which regulates a lot of the blood vessel dilation, for increased circulation of oxygen, nutrient transport, etc. You have the ion pathway, the ion signaling along the membrane, that becomes really important in regards to any kind of energy production, transport of substances through membranes. You have the glucose, regulation, fatty acid production, which then also relates to steroid production like testosterone, DHEA, estrogen, progesterone, and all the other steroids, plays a huge role in that. And then also, obviously the metabolic aspect, the mitochondrial activity, working all the different complexes. So these are some of the functions that AMPK, these are primary functions that it regulates and it impacts. And then what can we do then to control the AMPK or activate it? We talked about some of that, regards to agents that you can ingest, but then also lifestyle habits that you can incorporate in order to be able to increase AMPK.
Okay.
So was that it? Did that give us a little bit in a nutshell?
Yeah, that was good. That's what we like, though. We need a take home. So. Okay.
I just posted in the chat room the lab where you check the ADP, and it does have information on how it's monetizing the AMPK. Now, the other thing, Dr. William, about Dr. Peter, I did invited him on behalf of you guys, but it's in the group email. It's not in the group text because I mailed you and John and Dr. John. Right. So if you can respond to that the same way you text me in the email, then that would be good. So he will know that, hey, I'm being backed up by my team. And so if you can do that, it would be great. Okay, we'll do. Okay, so we are very excited. Dr. Karlfeldt, thank you so much. There's too much for me to process all at once. One question here: any specific brand of dihydroberberine?
I have a brand. Let me go and find the brand that I really like. Just one second. It'll take me a moment. Okay. So, those of you who were on when we started, I know Dr. Alassi, you weren't on. So we have. So again, our March 25th to 27th conference in Las Vegas at the Flamingo Hotel. I'll be sending out a flyer probably within the next 24 hours. If we've got it nailed down, then we've got Dr. Peter Mccullough, who is the giant of COVID, depending on who you talk to, either information or misinformation. But he's
you know, far and above the most well-known. I just did a Google search on them. I got 36 million hits on Dr. McCullough. We have Dr. Jacob Teitelbaum, who is the father of chronic fatigue syndrome. He's going to be online with us. We have Dr. Pauline Tai, who has done hormone things for many years. Felice Gersh, who we heard last week. Kathleen O'Neill Smith. These are, you know, the superstars of anti-aging medicine, and they're all coming to our conference, which is quite a coup. We also have Dr. Francisco Lozano, who's online with us here. And if you could unmute yourself and introduce yourself, Dr. Lozano, we'd be happy to greet you. We're happy to have you with us also. Anybody who has contacts that we think that might be interested, please either forward the brochures that we're going to be the emails that we're going to be sending to you with the program information, or give us their contact information, and we'll get in touch with them. The hotel has a special room rate for us that is just at this point. We got a special room rate at the Venetian for which is admittedly a nicer hotel. It's going to be less than $100 a night for 4 nights at the Flamingo, which is right on the Strip. It's a little bit older hotel, but you know, it's really a fabulous room rate. We have a nice room. We were there. We are going to have some great vendors, and hopefully we don't get COVIDed out. One last thing, I don't have a speaker for next Tuesday, so anybody who wants to volunteer, let me know. So,
Well, I would recommend Dr. Karlfeldt again to present platelets nanoparticle. I mean, he presented yesterday, and my audience are cheering, and so something, if you don't have, I mean, I know people, they want to see the change, but if you don't find anything,
we don't want to lean on anybody too much, you know. It gets to be a bit of a burden. So
Hey,
Dr. Lozano, if you could introduce yourself.
Sure, absolutely. Absolutely. Can you hear me? Am I okay?
We can hear you fine. We hear you fine.
All right. Great.
We don't see you, but we can hear you.
Okay, Dr. Clearfield, appreciate it. Yeah, so I'm Dr. Francisco M. Lozano from Mexico, and we do a lot of work and research in photodynamics and photobiomodulation and nanotechnology with third-generator photosynthesizers. So it really fits into a lot of, I guess, to different areas. We treated COVID for the past year through the pandemic using methylene blue, liposomal methylene blue with photoactivation, and we're extremely successful. So the same with photodynamics and photobiomodulation is, you know, it just covers all the fields because it plays along the lines from the cytoplasm into the mitochondria. So I think we'll have some interesting things, and it's, you know, it goes hand in hand with what we're talking about. It's also used as an anti-aging therapy only because it removes senescent cells quite effectively. And so a lot to talk about, and I'm sure it's going to be quite interesting to meet up and be able to converse a little bit about what we're doing in the field as well.
Hey, Dr. Halassa might have another pioneer for you here.
Yeah, I'm going to steal it from you. Would you be interested to present in my conference?
You do this to me every week.
I'm going to steal it. But I'm exchanging. I'm giving you Dr. Peter.
Yeah,
so Dr.
okay,
Peter is equivalent to 10 doctors, right?
No.
Well, that's fine, and we'd be glad to. We got a lot of nice information to share.
Do you work with Dr. Weber?
I do not.
So how are you doing the photodynamic with cancer? Are you doing fiber optics?
Yes, that is our next step. We're using everything from you know, from external you know, photo therapy through just external blood through a trivet. You know, this is with advanced light devices. Has
so you're doing cancer treatment, right? You're doing cancer.
Yeah, we are as well. We are as well. And, you know, we're stepping it up. As I stated, with nanotechnology, we're using things like spirulina, we're using things like curcumin. But, you know, as everything, these need to be selectively available and bioavailable. And, you know, a lot of them are water soluble. And so having to encapsulate them is a trick, and then getting them to their mark and being able to light them up. As you talk, different substances use different nano, you know, the diameter of light from 200 up to 1,200 of light. So, you know, for example, curcumin uses blue light, which is 420 nanometers of light, and that doesn't penetrate the skin very well. And that's when you use your fiber optics, down bronchoscopes and down laparoscopes and so on and so forth to your area. So, and again, I mean, this if you're using light in the upper range from 820, 830, 840 all the way to 1,200, that's about 10 to 12 centimeters of penetration. So you can use external light over, for example, liver cancer. If the patient's not morbidly obese, then you can access areas. So it's interesting, and the technology, I think, has been dropped off. I mean, this stuff that we've been using since the early 1900s.
How are you using the nano? What procedure you nano? Because we're doing platelets nanoparticle. Dr. Mike Karlfeldt, he is actually one of my chronic disease prevention and management specialists in Idaho.
Right.
So are you doing platelets nanoparticle? Are you interested in that? Because I can set you up with that.
Well, certainly, you know, we're looking at everything and anything to better the field. And so we do have pharmaceutical bioengineers on board from the Instituto Politécnico Nacional in Mexico City, which is a formidable university. And we do have our lab in the medical school university, and we're doing a lot of research from around the world, just for different people. So we have our own independent lab in the university. And so, you know, we right now are primarily looking at a lot, needless to say, a lot of people coming up with COVID. Some are using artesunate for COVID, and we're helping along with that research. And, you know, a lot of exciting stuff. But we do have a team where we're making the nanotechnologies, and we're looking at quantum dots and everything from carbon-60 to liposomal micellized and things like that. And we use from sonification, from bath rod sonification, all the way down through your nanolyzers or your microfluidics. And so, you know, we're looking at a lot of things. We're trying to primarily use natural organic stuff, you know, from just the available products that are out there that you know, emit and also resonate with light. So, you know, these are things. The problem is getting them, again, the small enough size down to 10, 30 nanometers around there to be able to penetrate into that mitochondria and get the effect from cancer. But, you know, that, again, the approach is either the vascularity, if you want to shut it down, you want to go into apoptosis, or do you want to actually go in and change that fermentation by knocking off the, you know, your nitric oxide from your mitochondria to be able to get or to push back into normalcy of a cell. And these are the things that we're looking at. And so a lot of exciting stuff, really is.
Can you share your information with me, and we can speak more after the meeting? Because I pick up a lot of your mind, and I think there's a lot of commonality, and I would like you to join our clinics that we have. We have 10 clinics, and Dr. Karlfeldt is in Idaho. He's enjoying what he's doing, and we're adding a lot to what he does. So we can do the same thing with you. So if you can share your cell phone number. My cell phone number is 713-291-6123 for everybody.
I'll get you his contact. Okay.
Yeah, just give me his contact. And hey, Dr. William, don't worry. Yeah. I'm going to pay you back.
All right.
That,
well,
you know, we have things under the table.
All right. Well, my immediate need is a speaker for next week. So.
I told you, if you want if you don't find anybody, if Dr. Michael Karlfeldt has time, he presents a platelets nanoparticle, and all the audience are wowing. I mean, this is like
are you glad that he's volunteering you again, Michael?
Dr. Clearfield?
Yes.
I sent you a message. Did you get my message on the chat?
No. Oh, you can present. Okay, Dr. Zarin. Okay, we got Dr. Zarin. You're off the hook next week, Mike. Well, we need somebody the week after.
Okay, I'll be
Good. You're
presenting
on.
at Dr. Halasa on
You're
Monday, so I
You're
can
on.
present on Tuesday.
You're
But
on.
the thing is, I would like to know what topic would you
All right,
interested in?
I'll bring that up with you when we're done here, okay? We
Okay.
don't want to bore the audience with all the back room stuff, okay?
Okay, okay.
So, yeah, I think I did. Okay, I think I answered everybody's questions in the chat. And we did get is there a brand? We got a brand here by Endurance Products, dihydroberberine. Question about live demos. We're looking to do breakout rooms where we're going to be able to do live demos or sort of longer presentations than the 45 minutes to the hour, which are the kind of the standard ones. We are osteopaths, so we may have an osteopathic manipulative component. But if we can get a live demo of, I don't know what's practical to bring with you, the methylene blue and photodynamic therapy, that would be great. Right. That would be terrific. Sure. So anybody has any ideas, that's practical, let me know, because we do have a breakout room available to us, if necessary. So it's separate from the main hall. So please, if you go to our,
I can get you Dr. Marino with this probiotic spirulina. Do you remember that guy, the Italian guy with a heavy accent, talking about spirulina probiotic?
I think so. Yes.
Okay, he can be that, and he has a company, so the company can also be a sponsor there at exhibit.
Okay, all right, get me that information.
I'll do that.
Okay, so aosrd.org, that'll take you to our website. That'll get you all through to registration for the conference. Please don't miss it. I'm telling you that you would pay $2,500 at A4M for the people that we have coming easily, probably more. We're 1/5 that. So let us, and we'd really like to have a nice crowd. We're also going to have it virtual online. If traveling's an issue or COVID becomes a problem again. So, but I'm really going to push to do it live. Last year we did it on our vaccine passports needed. I don't know. I will let you know ahead of time. I don't at the moment in Nevada, no. And my personal opinion is no. Not that I matter. But I did go to A4M, and they made you sign a waiver. Like the week before, they sent an email to everybody. You had to sign it that if you got sick there, it wasn't their fault. So I guess we're going to have to end up doing that too, I suppose. So anybody else have anything else? Okay, Dr. Zarin, you're on for next week. You'll send me a topic. Dr. Karlfeldt will keep you in the back burner again. We don't want to press too much. It gets to be a little bit burdensome. Dr. Patel, I see you're hiding there. We're going to get you also. So, anybody else have any other questions? David Kahn, you're going to be exhibiting for us, and John. We're a lot less expensive than A4M, and you're going to have more fun than we do. So, okay.
Sounds good.
All right. So for you guys, the vendors, go to asrd.org .sponsors or /sponsors, and it'll get you all through that also. Dr. Lozano, thank you for being on tonight, and we look forward to collaborating with you more.
Sure, absolutely.
Kate and Marie, thank you for being here. Dr. Zarin, of course, Ron, Dr. Cruz, Dr. Peterson, everybody else who was on that's left. We really, Dr. McCullough, thank you all for supporting us. We're still working on trying to get some CME credits somehow, if I can figure out how to do it without being burdened down with paperwork for these lectures. So I vow to have it done before I'm no longer on this side of the earth. So we'll do our best. We'll do our best. And with that, one last thing, Dr. Burgess, the AMA will be sending us $11,000 for the OMED program we sent to them last year for 2020. So we'll make sure that we got the 2021 done also, which is a kind of a nice little bonus. I wasn't expecting anything. They never said a word that anybody had bought our program, and it was $295 for our lectures. So we're getting $11,000 from them, which is a kind of a nice little surprise. So
Bill Clearfield, you're doing an excellent job keeping this boat afloat and going in the right direction. So thank you very much.
if we can only get them to let us change our name to Integrative Medicine, I think we'd have it knocked. But I haven't given up on that one yet. I'm just going to have to go about it a different way. So, okay. So with that, I want to thank you. I'm actually meeting with our, we have an event coordinator that we hired this year also, by the way, and she's going to be here in my office in about 10 minutes. So we'll keep you posted on what's going on, with that. Okay. So John, thank you so much for always being here. Dr. Gerber, thanks for joining us. Maybe we can get you to do a talk for us on a Tuesday night. Everybody else, have a great week. The start of a new year. I will have our lecture up on website within a day or two. Okay. And with that, any questions, any comments? Dr. Karlfeldt, again, if you're still on, thank you so much for being with us. And we're going to say goodnight for now.
Dr. Clearfield?
Yes.
Just a second.
Yeah.
I need a 2 minutes video from you as last time for our global conference.
Okay.
Please just prepare it and send it to me. If you can do it by the end of this week, would be great.
Okay. I was going to do controversies in hormone replacement, if that's something that you might be interested in. So progesterone after hysterectomy, yes or no, and testosterone in women. Is that something that they would be interested in or no?
No, I'm not talking about your topic. For promotion, do you remember last conference?
Yeah.
Video just for promotion.
Oh, you want a video?
Yes.
A video. Okay. Yeah. Okay. Yeah. I'll take care of that. Yeah.
Okay. Thank you so much.
No worries. Okay. Thank you.
Dr. John Burgess, great to see you. Great to see you.
Soon.
See you next week. Bye-bye.
Bye.
Bye. Bye, Joel.
You look okay.
Bye, Dr. Zarin.
Bye, Dr. Zarin. Thank you.
Bye, everybody.
All right. Good
Good night,
night.
everybody.
Happy New Year.